Hello all. In this video we will be discussing about list and tuple. So this is the start of the Python data structures. So in this video I will discuss list and tuple, and the next video we will be discussing about dictionary and some of the hands-on exercises on various data structures in Python. Okay, so a list which is very important, very useful data structure in Python, widely used. This is a collection of different data types together, different objects together, right? It holds the arbitrary data, it holds the heterogeneous, it is a heterogeneous collection of data, right? So it is like arrays in C, those who have some background on C. So it is like arrays, but it is not similar to arrays, because arrays holds only one type of data in the C programming, but here this is very similar to array, but it holds various types of objects together, right? So the syntax to declare is we can use the square bracket. Let's say my list, I create a new list here, and I can create some numbers here, and this is how I get a list declared and created for us, right? So this is of type list. So if I print this holds this displays all the numbers which is there in the list. So looking at this, you may observe that this is a sequential data which is held in this particular object, correct? So moreover, list is iterable objects on which we can get any indexes, right? Using any index we can get any value from the list, right? So at the 0th index we find the very first element, and the first index 34, second index 56, and so on and so forth. Okay, however we can also have different data here. We are not restricted to only put numbers or numeric data. We can have, let's say, name. Okay, we have, let's say, number. We can have let's say a floating data point, floating numbers. We can have high. So everything is possible. It can hold any type of data. It can hold list inside a list as well, because list is a type of object which can be used inside a list. Okay, we will be looking at that soon. But one thing we observe here is this is a sequential collection, right, where we have every object placed into with a sequence, and that can be accessed using the index, right? So for example, LST of 2. Okay, you see that it's a 45, and this is a numeric 45, right? And if I say LST of 0, that is a string 45. Okay, that's how the difference, that's how we can access the various elements in the list. And now let me help you understand one more thing here is, suppose if I print LST1, obviously I get Akash, and suppose I want to print A, capital A, right? So that is also possible. If I do this, I get Akash, and on top of it, if I put once again the index operator, and remember this index operator, we are trying to work on the string there, right? So Akash. So the output of LST of 1 is Akash, that is a string. So I can apply once again the index operator on the output, where the 0th index value will be A, capital A. Okay, so that's how we can do, and we can also do a negative indexing, needless to say, because this is another type of iterable object, and we have seen how negative indexing can be used on any iterable object. For example, we have seen for the string. So similarly, we can do get the last element from the list using -1 index, and that's how I get high, and LST of -2 will give me 8, and so on and so forth, right? So that's how the negative indexing works. Just for you, we may write something like this, because the output of negative -1 is high, and on top of it, if I apply once again the index 0, that gives me h, or I can do once again -1, right? -1 gives me I out of the last string, because the first part of this statement gives me the last element of a list, so that is high, and then the second part of this expression is giving me the last element of the high, right? Because high is also a iterable object, that is string. We are getting last element of or last character of the string. Okay, so that is about the basic operations on list. So we can also explore what are the functions available for the list. Okay, for example, dir function, we have already discussed how dir we use for looking at the attributes and functions available for any object. Okay, here we have a list object, and in list we can see that append, clear, copy, count, extend. So these are some of the most useful functions available which we can use on the list. Let's say I use append and I type 99, right? So that is 99, and look at this, what happened. So the 99 is appended at the end of the list. So remember, this is a sequential collection, so a sequence matters, and append will append the whatever object we are trying to put into the list, that can be put at the end here. Suppose if I do 9.9, so obviously this 9.9 will be the string, the float value which is placed at the end of the list. Okay, so this is how list looks like. Any guess, whatever we are inserting is at the end, or any guess you have if I want to insert somewhere in between, right, somewhere here, or maybe at the start, right, but not at the end. Okay, so obviously our friend dir function will help us to get some more functionalities available. And if you look at these functions, so I think insert function looks similar to what we are actually looking for, right? So what we can do is lst.insert and check how to use insert, how to check how to use the insert function here. So you can check the help page, isn't it? So you can simply check insert object before the index, right? And this looks like very a simple explanation, but precise what exactly we are looking for. So insert will insert before this particular index whatever we specify. Let's say I specify 2, okay, and the object would be let's say new data. Okay, so the new data, that is a string object, will be inserted into LST, that is the list, at the second index position, right? And obviously now at the second index there is no 45, but there is new data, because this is a 0th index, this is the first index. Now second index is no more 45, but that's a new data which we have just inserted. Correct? So that's how we can use insert function. There are other functions. I want you guys to explore extend function and come up with the answer. This is your homework, and maybe I will discuss this in the next session. Homework is to understand the difference between the append and extend. Okay, so let's try and explore. Today I'll be explaining you something called pop. Okay, pop is another function, right? So if you check in the list, so it removes the item and returns that item at the index, right? So whatever index we are specifying, so at that index the element will be popped out of the list, right? For example, if I do 1, okay, 1, there is Akash, correct? So if I run this command, so Akash is removed out of the list, and that is returned by this function. Okay, I can probably assign this to somewhere, some other variable as well, right? Let's look at the data now. So in the data you won't find Akash now anymore, because Akash is popped out of the list, and now you don't find that here. Okay, let's write here. So n equal to lst dot pop, and I want to remove let's say the last element. Okay, how to remove the last element? So I have to count the index, or I have to use -1, or even if I don't use anything, by default it pops the last element, right? Look at the output here, help page here. So the index is by default -1, that is -1, that is last element of the iterable object. So we don't have to specify, but yes, if you check now, n is having 9.9 and your list is no more holds 9.9 now. Okay, so that's how we can use pop function. Many times if you don't want any element out of a list, so you can easily remove from the list. Okay, that makes this kind of a data structure a mutable data structure. Okay, list is mutable data structure. Okay, the nature of the data structure, which is where which we can alter, we can modify, is called mutability, right? So here if I say id, I hope we have discussed id. Id is a built-in function which gives you an identifier in the memory, right? So where this is stored, okay? And usually the memory is in the hexadecimal, so we can use hex as another function which will give you the memory address in the hexadecimal format, okay? These are a couple of functions which we haven't discussed earlier, I think. Now we can understand that id is a identifier in the memory. So for example, we discussed earlier about the piece of memory, how to allocate and how we give a reference to the particular memory, right? So this is how we create a simple memory where 10 is the integer object and x is reference to this particular integer address. Remember, in memory there is always an address associated with any variable which we want to use, okay? So let's say that is a hexadecimal address, so some kind of a value there, right? So you can just imagine some value is there, okay? The moment x refers to somewhere else, okay, then this particular reference will be broken here, and this memory will be cleaned up automatically, and this space will be freed up, okay? But there is another space associated with another piece of memory where x is referring to. Okay, so that's a simple memory, how memory is arranged, or how memory is reserved, right, for any operation. So similarly for list, there is a memory allocated, right, and we can see the memory address like this, okay? Let's understand, okay, if I remove something from the list once again, okay, I use pop and I see that something got removed, right, and but still you see that the address is same, because wherever we have your list, so list is still holding the same address, means the original list is not getting cleaned up or removed, okay? Only the element is removed. So that is possible in list, right, where I can add something, I can delete something. The manipulation is possible, right? I can also do access, let's say second index we have 45, and I can just do addition to this, I add suppose 100 to the 45, and I check that what is equal to, okay, and I check that LST is now updated with 145, because it was 45, now it is 145, okay? That means list can be modified, can be manipulated, and still the address is same, okay? So we are not changing, right? But unlike a string, okay, I hope you recall a string, I can't I can access the any index, but I can't change it to with some other character, right? If I try to replace P with, let's say, capital J, so that's not allowed, because string is immutable in nature, okay? We can't change the string, okay? And obviously if you see this address here, so address of S is like BC8, and now if I say S equal to, I write something like this, right? So it is now we are changing the reference. Earlier S was referring to Python, and now S is referring to Zython, right? And that's the reason if you check the address of S, your address is getting changed, okay? This memory is cleaned up and a new memory got allocated, right? And that is the nature called immutability. That's how it is working internally, and that's why strings are immutable. It won't allow us to change any character, though we can iterate over, but we can't change any character out of a string, okay? But the difference is when we come to list, in the list we have that flexibility where we can go and edit any element of a list, okay? And that's why list is mutable data structure. List is mutable in nature. Okay, I hope you understand this. Let's say LST, we have this data available in this in LST, and we can see that a list can be modified, list can be altered, list can be stretched, or we can expand the list, we can squeeze it, we can remove some of the elements, we can shorten the list. So based on your requirement, the list is a very flexible data structure, very useful data structure one can use for their daily programming in Python. Okay, so let me help you understand. There is a function len, and we have already discussed len. We have used len for Python, right? Python is fun. Do you remember? There was a length, and the length was basically we tried this way. Okay, Python is fun, and once we have done this, we could say that this is the length of the string, right? Because string is iterable data structure. Let me write down this summary here quickly. String is iterable and immutable data structure, and list, which can be declared using this square bracket, okay, and which is iterable as well and mutable in nature. Okay, and this is indexed, by the way. This is as well the indexed data structure. Okay, so this is a summary we will carry with for the further data structures when we discuss. So length can be used on the list because list is iterable object. So if I check length of LST, I will see that the 6 is the length because there are 6 elements inside a list. Correct. So there is also a slicing concept which we discussed. There is a positive indexing, there is a negative indexing. So similarly, we can have the index which we can use for slicing a list. Okay, list can be sliced, and remember the slice of a list is a list itself, right? So very similar to the string. When we want to slice a string, the outcome is string only, right? So similarly, when I slice a list, so we get a list as output. Okay, so this is how we slice. So there's no difference in the syntax. We can very well do take only the the first 2 elements, or if I want to take only the last 2 elements, I can do this, or maybe from the second index onwards, I can take all the data from the list. Okay, so that is possible, and there's also a possibility of using similar syntax for reversing a particular iterable object. Okay, so meaning I will just jump onto string again, just to make sure that you understand the concept step by step. So here, if I use this negative step size, so everything gets reversed. Okay, so I think we didn't discuss this earlier, but if you are very clear with how indexing works in a slicing, then you can just tweak that to try different indexes, and for a negative indexing, so it starts in the reverse direction. Okay, and obviously we know then this is how we can use the technique to reverse a particular iterable object. So accordingly, we got reverse the entire list what we are looking for. And remember, your original list is intact. Okay, we are not changing in memory there, right? So if you want to reverse this and put store here somewhere, so reverse LST equal to, you could do that, and now you have LST and you have reverse LST, so both are now available for you. Okay, can somebody help me understand how to reverse this data inside a list? Yes, take a pause, solve this. This is interesting exercise. Now what I'm looking for is my output should look like this. Okay, the output should be instead of new data, I'm looking for ATAD space WEN capital, right? So that's how I reversed. So I just want to reverse this one, right? Just pause this video and guys try to solve this. Okay, I'm sure you can solve. So yeah, let's go to the solution for this. If I want to reverse something, let me do LST, or I have rev LST, right? So reverse LST of which value it is, -2. Okay, and now I want to assign this with the same data, but it should be reversed. Now same data is a string, and string can be reversed. This is what just we have seen, right? So it was not really a tough exercise, and I'm sure you guys understood this because we just have seen how to reverse a string here. right? And what I'm doing here is I'm reversing a string which is a part of a list, that is the second last element in the list. We can pull out the second last element from a list using -2 index, and since it is a string, we can go and do a reversal. That means using a slicing concept, we reverse it because string is iterable object. So we reversed and we assigned back to the same index in the list. So that's how we could reverse the string. Okay. So there are so many such small exercises that will help you understand, practice. So keep a note of it, try on your system. I hope you have already solved this issue, this particular small exercise, and if you have solved, I'm very sure that you understand the right basics of list, data structure, and string. So one more important thing is to add into our description, it is iterable, mutable, and index, right? We have said that it is iterable. Let's try and see how we can iterate. For example, if I run a for loop on a iterable object, I can do that using for ELE in LST, right? And let's see what is the ELE it prints if we try to iterate over. So see the magic here. So we are now able to iterate over this particular list and get each element at a time in every iteration. Okay, so any guesses? What do you think? What is the output of this? Or can we do, is it a valid statement? Okay, just think about it. Okay, so yes, this is valid, because remember, if I slice a list, the outcome is also a list, and since list is a iterable object, we can iterate over the output list, right, which is the outcome of this particular selected section on the screen, right? So this way we can get the elements of a list, that is first 3 elements, right, up to 3 but not including 3. That 3 is the index, and index starts from 0. That's why 0th index 45, first index new data, second index 145, third index is not considered because slicing works up to that index but not including that index. Correct? So yeah, so this is the small hands-on for how list is used in Python. And let me also help you understand one more function called is instance. Okay, so this is one more useful function in Python. For example, if I have I equal to 10 and we see that type is a function which gives you a type, right? Is instance is similar function which returns a boolean outcome if the specified object under test is of type integer, right? Yeah, it is of integer, that's why it says true, right? The moment I say it is str, so it says false because I is not a str, not a string. Okay, is instance, if you check a help page, I press a shortcut for this, shift tab. Okay, I can see the quick help page here which returns whether the object is of type instance, whichever we are specifying here, a class or not, right? So that's how we have just checked whether it is a list string or not, or integer or not, right? So is instance, I will also check if LST is a list or not. Okay, and yes, true, that is list. Okay, so this is another built-in function. So in addition to what all built-in functions we have seen in the last sessions, so let me add up this there as well. So built-in function, range, after that we have seen is instance, we have seen ID, we have seen hex. Correct? So these are some of the built-in functions we have been adding to our total collection, whatever we have been using this. So let me just carry this here in the latest notebook. Yeah, so these are like kind of short notes which we will probably refer. If I have missed any built-in function, please add it in your notebook which you are preparing along with my practice notebooks. So that will be helpful for you to understand how many functions we have seen. Okay, so now there is one exercise program. Okay, exercise for you to sum all the sum all integer and float numbers in a list. Okay, so quite interesting example. For example, my input list is let's say I have 23 or 2 comma 2 comma 5.7 comma high comma 8 comma 9 comma int. Okay, I take a simple small example. Okay, so the outcome I'm looking for is it should add 2, then 5.7 and 8. That's it, because this is a string. I'm not interested to deal with the string here. So except strings, everything should be added up. Okay, so how to do that? Simple. For element in this particular list, I can simply print the elements, and I see that I'm getting every element at a time, right? So it's just a matter of adding. So addition equal to, I make it a 0 first for first time, and then I use addition equal to addition plus this particular element, right? So this would have worked if I have all the numbers in the list, but obviously it won't work when it finds a 2 that is a string, right? So because we can't add a string into a number, right? That's we have seen somewhere earlier. Okay, so what we can do is we can check is instance and every element, okay, if it is float or integer. Okay, if this is true, we can add. Okay, and let's print addition, and I can see that 10 is the outcome we got, right? But 2 plus 8, that is 10, but somehow 5.7 is skipped, and I don't want to skip that as well, right? So we can use is instance once again and check if element is float, and then also I want to consider this addition, right? So that's how we can make it. So alternative to this is you can also use either int or float in a single command. Okay, whenever possible. Just a moment. Yeah, syntax. Okay, so here this is also possible. You can just give one group of objects together. So that is called tuple, which we are discussing soon. Can be put together in the isInstance function, so that element, whether if it is integer or float, it will be considered for addition. Otherwise it won't do any addition, it will just continue to the next iteration, right? So keep on doing. So that's how we can add the elements. Okay, so the another important exercise, this a quick thing. Let's add all the numbers at even index in a list. Okay, and here the assumption is assume list is having all integer numbers. Okay, I just make it simple, okay, for your solving this problem. So let's say I have 1 comma 2 comma 4 5 6 7 whatever, right? 90 or 9. So these are the number of elements in the list. Now for example, if I want to move on with the index, okay, suppose idx, in a range function I use along with the length. Now look at this, we have already seen how length can be used with any iterable object, and this gives you some number, right? So what number it will return? 3 plus 3 plus 4. There are 10 elements in the list, so the output of length of a list will be 10. Since range generates the sequence from 0 to 10, not including 10, so we will be having all the indexes. Okay, here I will do check if index is modulus division, if it is equal to, sorry, here, right, 2 equal to 0, that means we are considering only a index which is the even number, right? Then I will add. Okay, so addition equal to addition plus LST of idx. Okay, we will consider only that in addition. So this is how we can do. Let me just try it, see if it works. And I think it worked, right? So index 0, the 2 will be added, and then 5 7 7 plus 9 16 16 plus 3 19 19 plus 8 27, and that's right, the output we get, Okay, so that is a quick exercise. So this helps you to understand how to iterate, how to find out some functions, how to use for loops, if constructs, the operators and iterations and additions. So those are the things we are trying to explore here. Okay, so the next data structure is something called tuple. Okay, tuple is a collection of heterogeneous elements, and that is exactly same as a string. The only difference is tuple is immutable in nature. Okay, so let me explain what does that mean with the help of an example here. So we get tuple, and tuple can be declared using a round bracket, right? It is also an iterable object. It is also an indexed. Okay, I will write this first. So, and it is immutable. Okay, except this immutable behavior. So everything is same. Okay, there is no difference at all, right? Only thing is, when I say immutable, so we can't modify, we can't change anything into the tuple, and that makes it faster as well. Okay, so look at this. We have seen some basic stuff, and let me see what a tuple looks like. So it is a comma separated values put into a round bracket. Okay, that's how we declare the tuples. So it is immutable, hence it is more efficient. Okay, efficient in terms of processing, in terms of memory as well, right? So because it does not have to maintain the all the state, what all the parameter, what are the elements are there. So suppose we want to pass some object into the function, and many times we want to make sure that those objects are constant. Okay, so we want to make sure that this things should not be changed, right? So that is a convenient place where one can use tuple instead of a list. Okay, it is simple, more efficient in terms of memory and performance. And if you want to use some kind of a temporary variables, right, so tuple is something one can preferably use. So let me write down a simple tuple. Here suppose I write okay, this is a simple tuple. Here we can also have, by the way, any other data structure. Okay, so type of TP, you can see that it is a tuple. Okay, and now obviously tuple dot append, if I try to append 8 at the end, obviously it won't allow, right? It is very similar to string, as string does not allow us to change any character into a string. So tuple won't allow us to add something into a tuple or change something into a tuple. For example, right, TP of 1 equal to, I want to make it 88, it won't allow me. Okay, the reason being tuple is immutable in nature. It is kind of a read-only data structure. We can't change anything, but we can iterate over. Okay, for example, see, print element, I can see that all the elements are getting printed. Okay, so obviously TP dot append is not available, TP dot insert is not available. So what is available then, right? Let's try and see. So TP and dir of TP, and it has a very limited functions, only count and index. These are the only two functions available in tuple compared to what was available for list, right? If you check in the list, you will see that the index is there and the count is there, but there are so many other functions as well, right? So those functions are not available for tuple. Reason being, tuple is immutable in nature. Okay, so yeah, that's it about the tuple. Tuple is immutable, more efficient, faster compared to list, and list is widely used, and tuple is kind of, I would say, a rarely used data structure, as whenever you have a need of making some constant data, so that is the place where you could think about using the tuples, right? I will take another example. Let's say new TP equal to so I can have tuple of tuples as well. Okay, so we can have some data, maybe 4, 5, 6, maybe 7, 8, 9, right, and so on. So whatever, I mean, it is just, I'm taking a simple example for I in new TP. Okay, and now suppose if is instance I is a tuple, Yeah, if it is true, then I want to run over this tuple again. J in I is a tuple, right? So I can do that if is instance j comma tuple. I will simply iterate over once again. Okay, so this is more about the iterations. We are going through tuples, tuple inside a tuple, and so on and so forth. Okay, so I'm not going to do this too much about the moving into the very many layers of tuple, but the point here I'm trying to make is we can just print the values here. Okay, maybe I will use one more loop here for k in j print k loop. That's okay. Okay, so we can have something like this, and else we are in j loop, something like this. Okay, I'm just trying to make you understand how we can have the various layers of tuple. I loop. Let me see. So it says j loop, j loop, j loop. Many times it is printing because we only have this. There are three tuples, and whenever we are going through each tuple of this, there are 9 times we are coming to only this loop, right? So the point here is tuples can be nested. Tuples means tuple can have a tuple inside it, or it can have some values. It can have string. It can have another tuple in it. Okay, 4,7,6. It can also have a list inside a tuple, right? And it can also have a floating point number. So this is also a possible data structure. And yes, obviously, sorry, just a moment. Yeah. So here, if I print TP, I can see that all these elements are stored. Okay. Obviously, if I try and explore -2, just a moment. Yeah, if you try and explore -2, you will see that 8 and 9, that is a list. Okay, so and then if I check 9 and equal to 10, so that kind of manipulation can be allowed, but to access 9 I have to use -1. Okay, so TP. Now check that 9 became 10. The list is immutable. List is mutable. That's why I can change, but I can't change the value. I can't change the whole list here. But inside the list, I can change something, right? So that's something interesting. You guys have to explore this, play with this, run some exercise. Try some different indexes, possible indexes. You try and explore this. You will discuss so many things. Okay. By the way, a list is also a similar kind of data structure where we can have anything inside this particular data, right? So only the best part of it is you can manipulate, you can change the entire things, right? If you want to change, let's say -1 to let's say 7.1, and that is possible, whereas this kind of change is not possible for a tuple. Okay, so hope you got the fair idea about what tuple is, how we use tuples, and how it is different from list. So list and tuple are very important data structures in Python, guys. Okay, so keep practicing. In the next video we will be discussing about dictionary and some more exercise along with the tuple, list and the dictionary in the next video. Thank you for watching.